Assalamualaikum and hi, my name is Khairul Izzat bin Mohd Jeffery and my student ID is 2019406554 and my supervisor is Dr. Wan Rozano binti Muhammad Hassan. Welcome to my presentation to all the panel and all the viewers. So today, I'm going to present about my research that is the anti-malarial activity of caffeine in Plasmodium berghei ANKA affected ICR mice. So here are the overview of my presentation. Moving on to the first part, which is the introduction. So what is malaria? Malaria is an inflammatory disease that is caused by protozoan parasite known as the Plasmodium species. The symptom of malaria infection may vary from cough, headache to abdominal pain. The justification for using ICR mice model for this study is that according to BACE 2012, by using ICR mice model infected with P. berghei ANKA strain, the clinical feature of human cerebral malaria can be reproduced. Moving on, the purpose of using caffeine in this study is that because caffeine are known to exhibit anti-inflammatory effect. There was an in vitro study of anti-plasmodial activity of caffeine that has been reported by InSwasti in 2015. However, there is no study yet to be done on anti-malarial activity of caffeine. Moving on to the next part, which is the problem statement. In 2020, while everyone was still looking for the COVID-19 vaccine, a total of 241 malaria cases were reported throughout 87 malaria endemic countries in 2020. This number is considerably high, with 59 malaria cases per thousand population at risk and 15.3 deaths per 100,000 population at risk. Also, due to the emergence of drug-resistant strain of Plasmodium falciparum, this has contributed to the increase of morbidity and mortality rate in malaria. Thus, there is a need for an alternative treatment for malaria. So, the objective of this study is to determine the survivability of ICR mice treated with caffeine. Second, to determine the anti-malarial activity in Plasmodium berghei ANKA affected ICR mice. And also, lastly, to determine the histopathological analysis of P. berghei ANKA affected ICR mice treated with caffeine. So, here are the methodology of this research. First, we test the ICR mice for the survivability of the non-infected mice. The mice were divided into 4 groups where they were given 85% saline solution, 2.5, 5, and 10 mg of caffeine, respectively, through intraperitoneal injection. The toxicity effect in terms of body weight and gross behavioral changes were observed for 30 days. Next, we proceed with the 4-day suppressive test, where we inoculate the mice with P. berghei ANKA strain and treated it with different compound. The negative control were given 0.2 ml of saline solution, while the positive control were treated with 10 mg per kilogram body weight of chloroquine. The 3 test group were treated with 2.5, 5, and 10 mg of caffeine respectively. The mean parasitemia count and chemosuppressive percentage were counted on day 4 post-treatment. The effective dose of treatment were determined by the percentage of chemosuppression. Lastly, the histopathological analysis were done by extracting and processing the brain of control group and the effective dose group. The brain were observed for signs of infection such as inflammation and sequestration of PRBC and etc. So, here are the results of the survivability test in terms of body weight changes. The significant body weight in each group can be seen. The significant body weight changes in each group can be seen on the first 4 days of drug administration. This is most likely due to the stress when receiving IP injection. Starting from day 6, The average body weight increased steadily without any sudden drop throughout the whole 30 days. Hence, there is no sign of toxicity in terms of body weight changes. In terms of gross behavior changes, no sign toxicity such as diarrhea or reduction in locomotor activity can be seen. No deaths were also reported from each group, and the data were compared with previous toxicity study of caffeine on mice. The results were in line with the data collected, where the toxicity effect can only be seen on dosage above 40 mg per kilogram body weight. So here are the previous study on caffeine, on the toxicity effect of caffeine on inbred mice. Moving on to the next test. From the result of the 4-day suppressive test, we can see that chloroquine have the lowest parasitemia count at 25.48%, and the 10 mg treatment group come in second at 49.98%. This data was translated into chemosuppressive percentage using the formula of bracket A minus B over A times 100, where A is the parasitemia count of the negative control while B is the test group. The 10 mg group have the second highest percentage next to chloroquine, and thus 10 mg group were chosen as the effective dose. Here are the results of the histopathological analysis. Due to unfortunate circumstances, the brain tissue collected were damaged during the extracting and processing process. Visible tear can be seen throughout the cerebellum tissue. However, no sign of malaria infection can be seen as compared to the previous study. As a reference, this is the histopathological analysis done on brain of patient with human with cerebral malaria. This is the example, a classic example of malaria infection on brain. Visible ring hemorrhage can be seen in the gray and white matter of the cerebellum tissue. As a conclusion, further study need to be made to determine the potential of caffeine as an alternative for anti-malarial drug, as the current data is still insufficient. Here are a few recommendations for future study. First, we can use a wider range of dosage, since the dosage that were used in this study were only 3. Secondly, we could provide a better enrichment during in future study by providing a better environment and holding cage for the mice. This is to avoid stress and aggression, which could indirectly affect the result of our test. And lastly, a study of co-administration of caffeine with other anti-malarial drugs such as haloperidol and chloroquine can also be done. So this is the list of references that I will use in my study. With that, I end my presentation with thank you.